Hey everyone, my name is Rodrigo, and I'm a software engineer at Facebook on the real-time infrastructure team. And today I'll be talking about GraphQL and live queries. Before we get going, quick show of hands, who here is familiar with GraphQL? OK, a couple, not everyone. That's good. I'm glad I chose to include a brief intro of what GraphQL is for y'all's benefit. Yep. To set the agenda, first I'll cover just briefly what GraphQL is. This will be woefully insufficient. Very much encourage you to read up on it. I'll have some links at the end. And then I'll go into what is a live query. I'll talk about subscriptions and live queries. Both of these are things that we would use to build liveness in experiences, being able to not just request data, but push data to clients. So I'll cover kind of how they compare. Talk about why we have live queries, why we believe these are a useful construct. And then finally, talk a bit about how we implement live queries. I'm more of a back-end than front-end person myself, so this is where I spend most of my time on. So yeah, let's get going with this. GraphQL, put very simply, is a query language for APIs. It is a way of specifying a schema, being able to tell from the server, be able to tell your clients, here are the types in your system, here are the fields, here are how they connect to each other. And then also providing declarative language for clients to specify exactly the shape of the data that they need. And finally, a bunch of useful frameworks and tooling around it in order to do these things in a nice, type-safe way. It's a lot easier for me to demonstrate what GraphQL is than just explain it. So let's do this through an example. Suppose we're building an application based on the Game of Thrones universe. In this application, we would have a house object like House Stark or House Lannister with some properties, and we would like to be able to display this information in our application. In order to communicate this, we need an API. We can use GraphQL for this API. Pictured is a very minimal example of what a query would look like. On the left, and then on the right, there's a response. The tool you're looking at is called GraphQL. It's an open source IDE for developing GraphQL. The basics of what's going on here are on the server, we have exposed our types and our fields and functions. So for example, the house function takes in a house name, loads an object from that name, and then exposes fields that we can query on the object. These fields don't directly map to things on a database. They're just wrappers around functions that you may have in your language of choice. Once the server exposes this, the client can import this definition of the schema and query fields on it. So the application can specify, hey, I want to load a house, as well as its name, words, and bannerman. The application is free to choose what it wants to query. With GraphQL, we can not only read things, we can also write things. We have this concept of mutations in addition to queries. And here we have exposed a mutation called pledge bannerman. It takes the name of a house and adds a randomly named bannerman to its list. Like a regular query, clients can also specify what fields to read off the result of a mutation. It doesn't just return void. You can kind of get some more data out of it if you need to update your application state. And in this case, we may choose to get both the name of the newly added bannerman, as well as an updated view of the house. So the house's name and the list of all of the bannermen. And then finally, another construct that we have in GraphQL is subscriptions. These are used to as the name would imply, subscribe to specific kind of events. In this case, the client can create a subscription. The subscription is called Bannerman Pledged. You can specify a house. So you can say, I am interested in Bannerman being pledged to House Stark, for example. And you can think of it as whenever an event is published on the server, either you explicitly add hooks and have some sort of pub subsystem, or you have some event bus that you listen on, however you go about doing it. You can listen to these events. Similar to queries and mutations, with subscriptions, you can specify what the shape of the data that you want to read as a result of the subscription firing is. And so in this case, this looks very similar to the mutations before it, right? Subscription and mutation, they're kind of the dual of each other. We can read what's the name of the Bannerman that was just added, and then kind of fetch a list of things. One important thing about subscriptions is that you need an event for them to make sense. A subscription by itself, you can't just run it like a normal query, because you need, for example, in this case, to know what was the name of the Bannerman that was just added. So this is, in a very condensed version, the kind of constructs that GraphQL has to offer today. What my team has been working on is the development of live queries, which is one more construct for this toolkit. So let's dive into that. Say our application is interested in keeping this query updated as things on the server change. What if all it took was annotating the query to say, hey, we want this query to be live? And then the server can go figure out how to do it. What you're seeing on the screen is a live query. Really, this is all there is to it. It's a very simple concept. The big thing with GraphQL is that it's very client-focused, client-driven development. We want to be able to allow developers to declaratively say, I want this data to be kept live. I will leave it to you to figure it out. And that's basically it. A live query can be thought of, if everything works perfectly, would behave the same as a query that just polls infinitely fast. In practice, that doesn't work because servers aren't cheap. You can't do that all day. And so this is where building the right infrastructure to power such semantics becomes important. But really, that's all there is to a live query. You have a regular query. You specify that you want liveness. And then you leave it to the framework to provide it for you. So having briefly mentioned what live queries are, I would like to compare subscriptions and live queries. The big difference between the two is subscriptions are very event-oriented. A subscription doesn't work at all if you don't have an event. It is all about observing events, although in response to an event, you can go and query some bit of state. With the Bannerman example, part of the event integral to the subscription is saying, this is the new Bannerman that was added, but you can query the list of Bannerman back. With live queries, instead, you're querying the state. Those are state-oriented, so you're getting the list of Bannerman and whatever house properties. And you can go back and forth between these two things. States and events are very much tied to each other. If you have a subscription, you could subscribe to everything, all kinds of changes, and it'll fire constantly, and you'll get the latest state of the world all the time. And if you have a live query and you persist on your server the list of all events over time, then you can get updates to that list and see how it changes over time and reconstruct events from that. But it doesn't always work very nicely. So there will be some situations where these two, either choice works OK. If we're just trying to keep the list of bannermen who have pledged to the house updated, you could use a subscription that'll fire when a bannerman pledges. You can use a live query. Ideally, semantically, live queries align better with that, but subscriptions work as well. There's going to be some judgment call where there's this middle ground that'll depend a lot on your infrastructure and maybe some incidental factors. So why do we need live queries? We have subscriptions. They're awesome. Do we really need yet another way of doing real-time updates? I would like to work through an example that I think will motivate the whys of live queries. So back to our bannerman example, or back to our house example, imagine we extend our application and add a description field for our houses. And when queried, the description could read something like this. House Stark, whose words are "winter is coming." It is a barely existent house with no bannerman. The thing I want to point out here is this description is a computed field that depends on various pieces of data, including the house name, its words, and the bannerman. And for the sake of this example, assume that this field must be computed on the server side, maybe for translation purposes or to control how the sentence is rendered, however it may be. If this is the case, if we have this new description field and we want to keep it updated, how do we do that? So the obvious choice is we have subscriptions already. We could reuse our existing subscription call and simply add the description field to the list of fields that we query. Now, whenever a bannerman is pledged, the subscription will be updated. The description will be updated. And so this should work as expected, and it solves the problem. So far, so good, right? Subscriptions work. Why do we need live queries? What happens if we now introduce other kinds of mutations into our world? As our application grows and the world becomes more interesting than just bannerman pledging, we can add more things. So House Stark gets invited to a wedding, and suddenly it's like, oh, we lost a bunch of bannermen. Oops. It's not great. Winter finally gets here, and House Stark decides to revise their words. Dickon realizes he has a silly name and wants to change it. Great. You have a tournament, and the bannermen get ranked. Who knows? All of these mutations are individually straightforward, and you could create a new subscription for each mutation type and include the description field in that subscription. But you can imagine how that scales quite poorly. As different kinds of mutations come down the pipeline, developers have to remember to keep the description field updated as well. It's fragile. People aren't going to be great at remembering this. You can't just rely on developers being always aware, because that doesn't always happen. An alternate approach would be you could create a new description changed subscription call. And the way this would be implemented is by listening to all of the relevant mutations or publishing events whenever the relevant mutations happen. But you still kind of have this problem where a developer has to remember it's the name, it's the bannerman, and it's the words. And I need to make sure that we go hook into the code all the places that the description can be changed to keep it updated. And this is kind of OK still for something like a description. You rely on 3 fields. It's not a ton of cognitive overhead to keep that updated. But you can imagine, like, as your application grows and you have more complex dependencies for how fields are computed, it gets hard to ask a developer to go through all of the possible things that could affect some output. If you've ever had to worry about cache invalidation, this is basically the problem, right? And this really is where live queries shine. If we could allow the developer to say, the description field, I want it to be kept updated. You, the server, now have the problem of figuring that out. Then you have made the developers' lives a lot easier. They can produce more correct applications. They can just quickly write things on the client without having to go touch the server at all. Everything is great, except if you're an infrastructure developer, because now you have a really hard problem to solve. But yeah, this is really the crux of why we believe live queries shine is having a declarative way for application developers to say, I want to keep this updated. You figure out how. Is a huge productivity boost. It allows faster iteration. It's definitely worth looking at. So now let's talk a little about how we go about implementing live queries, the fun stuff. One valid implementation is polling. This is not necessarily very satisfying, but polling for live to replicate live query semantics work. This could be done on the client. Every however many seconds, you go refresh the query. With live query, you can even push this down to the server. You just say, keep it live. The server may have more context than the client on what's the current capacity of your system. For different users, you might have different polling interval rates, or for different use cases. Or you can imagine a bunch of things that a server could use to do polling that's a bit smarter. Although, even as good as you can get with polling, it's still going to be somewhat inefficient. There will be cases where you go to the server to get a new result, but the data hasn't changed. So can we do better than polling? The way we do better is through reactive data stores and implicit dependencies. When you run a query, the server would look at the query that you run, determine what its dependencies are. By dependencies, I mean if you go query some database, what was the query? And then you look at these data dependencies. You set up subscriptions to observe and be notified whenever data changes. And then you keep the results updated. Some existing tools that you can use today are things like Meteor, Firebase, RethinkDB. Here you can see RethinkDB query in action. As the data changes, the results update. It's all great and magical. And a simple application, like for our Game of Thrones example, could conceivably be built using existing tools, like existing open source tools today, without a ton of hassle. But it's with complexity, you get a lot of challenges. And so scaling all of that becomes interesting. The problem for us at Facebook was, how do we take our existing infrastructure and make it reactive? A reactive infrastructure, like put very basically, it looks kind of like this. You have a client, could be mobile, web, whatever. You have a stateful GraphQL server. Clients send GraphQL queries. They send requests and initiate some kind of response stream back. Similarly, the server, as it executes the query and resolves it, will set up subscriptions, response streams against some reactive data store, reactive database. And so whenever the data changes, it notifies the server, and then the server can notify the client. This is at its basic how a reactive infrastructure would look. Instead, though, where we start with, I think a lot of applications today would have something that looks similar to this, is an architecture like this, where you have a client, a stateless GraphQL server, and a data store, just MySQL or whatever. So clients send a request. The server gets the request and fetches data by sending a request to the DB. and goes back request response. With something just like this, you can't implement either live queries or subscriptions. You need some kind of stateful service to maintain connections to your clients and be able to push updates over those connections. If your code base is large enough, rewriting your server to be stateful might not be an option. Like at Facebook, we use PHP. As much as we would love to use just about anything else, we can't. It'd be very expensive to do so. So we have to find creative ways to work around it. And not all hope is lost. There are ways in which you can add statefulness to the system to take care of the things I just mentioned, while still maintaining some of that stateless server still in place. So the architecture now transforms into something that looks a little like this. And I'll go through the flow. A client issues a GraphQL query to the server, the stateful server, not the GraphQL server, just some gateway connection manager thing. The server sends the request to the stateless GraphQL server, PHP. The GraphQL server executes the request, much like it normally would. Except now, while executing the request and getting a result, it'll also keep track of what the queries were made, what were the MySQL queries or whatever other backend you have queries, and sends them back to the stateful server. Stateful server sends the response to the client. As far as the client is concerned, it's just been request response so far. But it also holds on to the data dependencies and creates subscriptions for them against the reactive data store. So now, when the data store tells our stateful server, hey, this data has changed, you probably want to go recompute, the stateful server can go execute against our GraphQL server and repeat the cycle. If the response changes, great, you push something up to the client, you establish your new dependencies, and you go on until the client cancels or goes away or whatever. So this is, put bluntly, data-driven polling. It's smart polling. There are a series of problems that we've run into when implementing live queries. These are very briefly some of them. I don't really have time to go into them in detail, but the big concerns are about efficiency. If you have a system that's optimized for request response, or just a system in general, it's easy to overfetch. In a reactive system, it becomes oversubscribing to things. It's easy to have noisy writes, things writing to the database that you're not really interested in responding to that can create problems. And the flip side is, in introducing all this magic around, yeah, the server can just totally figure out when to update your queries. There are correctness issues in making sure that your system can track all of the relevant data properly and update it as it changes, especially in distributed systems where you have consistency concerns. This becomes a whole can of worms. And naturally, these two concerns are kind of at odds with each other. You can be perfectly efficient if you never update, but then your correctness tanks. You can be perfectly correct if you're always updating, but then your efficiency tanks. So being able to reason about these things, provide tools for product developers to understand these trade-offs, and be able to select the right point in the trade-off curve is very important. So having talked about live queries and how they can be used, I hope you're as excited about them as I am. At Facebook, we've open sourced GraphQL and subscriptions, and there are many other people who are very involved in the GraphQL community, in the GraphQL APIs and language spec and all of this. And so this is something that we always have in the back of our mind. Live queries are something that are still being iterated on. There's a lot of details to figure out. And we hope to one day bring them to the broader community. But in the meantime, as I mentioned, there are open source components that you can use to build these things today. And we already have a couple of folks on GitHub who have built some prototypes around this. There's a pre-RFC discussing live queries. So you can definitely get involved and find ways to start playing around with this. And finally, if you're interested in learning some GraphQL, here are some resources. That's all I had so far. Do we have time for questions? Question? Yeah. Yes. Or, yep. Oh, yes.
So when I first heard you talk about the distinction between subscription and queries, it sounded to me like subscriptions were more of a push notification system and queries were more of a polling like you subsequently described. But I don't think that's accurate now. So could you compare and contrast the two a little better, or are they basically based on the same reactive data store?
Yeah, so they are not, and there are some, this is, I think, where some of the incidental factors start to leak. It is, boy, I don't want to say that it's easy to build a pub sub system. It's not. But a lot of, I think a lot of places already have pub sub systems. Subscriptions were built on top of pub sub mechanisms, so they kind of tie well to that infrastructure where you have a subscription that specifies a topic, some key that you're interested in, and you have a backend that can publish to that topic. And in our PHP code, you would specify, hey, go publish. We have seen a change for this subscription. It was only later that we started thinking about how do you make the data stores themselves reactive. And so these aren't built directly on top of the pub sub system at all. There are kind of other mechanisms in play in terms of like how you push things up. Push notifications themselves are like yet a different bit of infrastructure. So to some extent, at least for us, that was some of the infrastructure concerns leaking through into how things were developed and in what order. But that's not to say that if you're starting from scratch for a greenfield project, you could build subscriptions on top of a reactive data store just as well as live queries.
Hi, so this is brand new to me. So I guess what the question is, what is the state of the infrastructure right now? Is this something that AWS and Azure have already in their environments, or is this something that's still being looked at in industry?
I'm afraid I don't have a good answer for that. At Facebook, we have our own special Snowflake infrastructure that's built in-house. To the extent that I know some open source offerings, it was what I mentioned in one of the earlier slides. I unfortunately don't know what kind of offerings AWS or Azure or whoever might have as far as building blocks. Nope. All right. Thank you all very much.